Yes.
Hello, welcome. We are Exhaust Turbine team. It consists of Brian, Ron, and myself, Angel, and our advisors, Dr. Tremonte. For the past 15 years, we've seen a steadily incline as far as hybrid cars, and those hybrid cars use huge battery packs, and the way they are charged nowadays are very different forms. So, for example, the Prius uses the momentum of the brakes to charge the battery. What we've developed is a turbine fan that will go on the exhaust in order to capture that energy to go ahead and charge those battery packs for the hybrid cars.
For the type of turbine fan that we're going to use for this project, we're proposing to use a helical blade shape that would provide a more optimal efficiency for our system. At the moment, we have a current design that has a 90-degree angle change between blades at each of the ends. And through continuous simulations, we're going to receive different models or produce different models in order to find out which will create the best results for the type of testing that we provide in our system.
Here's how it's going to work. We have the axial turbine in the direction of flow of air. So this will allow us to reduce or almost eliminate the amount of back pressure into the engine system. The optimization we'll be doing will consist of analyzing the profile of the blade as well as the configuration of the blade to determine if we need more blades, fewer blades, or to cover a shorter degree angle. For fabrication, we'll be using fused deposition modeling, 3D printing, to fabricate the blades. We'll be using steel or other types of metals to produce the supports and the axis of rotation for the turbine. And we'll be purchasing appropriate bearings and the gears for the system.
As far as market, there's a huge market for hybrid engines. We have passenger cars, trucks. This is a picture of a Prius. So right now, Prius are the most commonly bought hybrid vehicles. And as far as trucks, that would be a really good market. Trucks transfer the products for almost every store in the U.S. And it'd be good to tap into that market as far as hybrid technology. Now, in August of 2012, last year, the EPA signed a regulation that from 2017 to 2025, all cars will have to meet a standard of 54.5 miles per gallon. So that's our goal, to be part of that upcoming market. And as far as impact to the environment, you have fuel reduction, approximately save 4 billion barrels of oil during that time span, and then reduce greenhouse gas emissions by 2 billion metric tons.
As far as for the challenges of our design, one of the big things in order for us to create an actual waste recovery system is to be able to maintain a positive efficiency of the system overall. And when it comes to the blade design that we're choosing, we're trying to optimize a design that would provide the least back pressure onto the system so that the engine will not put more work into it and be losing that positive efficiency that we're achieving. Another challenge in our design is the size limitations. As we're attaching the turbine fan into the tailpipe of an automobile, we'll be able to have the size of 3 inches and pieces there. We want to make sure that it's compatible with many types of automobiles of the standard sizes. And for the motivation of our project, of course, we're trying to achieve an optimal efficiency of the system, which is beneficial for modern hybrids today that are providing an increase in many types of ways of capturing or renewing the energy that is being lost, and also utilizing the exhaust energy of an automobile would provide in more of a increase probably in the cost when it comes to using the electrical devices in the cars, and reducing obviously as well fuel consumption, because the system will be reduced. We'll have a more efficient system, can be reduced the size of the motor. And that's the end of our presentation.
Like, thank you. Any questions?
Yeah, my question has to do with where is the
question number one. Where is the global component?
The global component as far as the, so well, the US at least incorporating the EPA regulations for the miles per gallon going down. So what that means is we're going to consume less oil, have to depend on less oil consumption over the world.
And the intention of design is also to be able to expand to other situations besides just exhaust pipes, such as the output of the air conditioner in a home or other high airflow areas.
Well, you were not very specific in addressing the global issue, so it may be implicit, it's not explicit, so I'm asking you to make it explicit. So you may need another slide dealing specifically with that, which will reinforce and or add or take away from some of these other information that you provided. The other thing is you're using a lot of graphics, and there are no citations for those graphics. They're not yours. So you need to address that. Does that make sense?
In a separate reference page or?
No, you just need a little caption under each of the visuals, under the slides.
Yes.
Go ahead. Actually, for this slide, are you guys sure that's the standard?
Yes, it was signed August of 20.
Because that's the corporate average, not the standard.
The corporate average.
The 45.5 mpg is a corporate average for.
54.5.
Okay, but it says it is. 54.5 is a corporate average, meaning that every GM must have a fleet of vehicles that meets that average.
Correct.
Yeah. Because when I read it, it sounded a little odd because it said 54. And when I read it, it sounds like every single car that GM produces must have a corporate average of 54.
Oh, okay. So more.
So they can have some guzzlers, and they can have some zero.
Right, so averaging
Right.
to that. Okay.
All right, sorry, I missed it. What are you guys actually doing? I'm sorry, I walked out. I don't mean to be a jerk, but
We're creating an axial turbine to go
Okay.
in the exhaust pipe of a car, which will
So
rotate.
what, are you putting energy in to turn that turbine, or what, you're just trying to condition flow out of the back?
We're just trying to utilize the wasted energy in the exhaust airflow.
Oh, okay, so this is gonna spin and you're gonna get some energy out of it.
Right.
It's like a
Okay.
turbine.
Turbine. Do you have any estimates about how much energy you'll get from that? You can probably try to do that, right?
Yeah, we're for
Okay.
testing. We're gonna do like a clear PVC pipe,
Okay,
print out with the 3D printer an actual blade,
right.
so we can do testing with airflow and see how.
But even then, so estimate some different speeds that this thing's gonna turn at, and figure out exactly how much energy you'll get out of it. Start there, I think. You know, you don't need a prototype, you don't need anything. Just how much energy can you get from something spinning this, because these things are small, right? I mean, it's inside of a
Right.
tailpipe, so just be careful that you're not engineering something to get, one LED light on the front of the car or something. The other thing, so are you trying to improve gas mileage? Why didn't you include that MPG?
Well, the reason we included that is because we're trying to harvest the energy and put it into electrical power. And so a lot of
Okay.
hybrids have batteries that can store that amount.
The battery packs.
Battery packs,
Okay.
and if you
It was in the
add
first
more,
slide.
you can reduce the fuel.
Gotcha, okay, so for instance,
Making smaller engines.
gotcha, right, okay, that makes sense.
So you're harvesting the energy in the tailpipe with that device. How do you transfer that into storage? I would expect to see some kind of a shaft from that.
Yeah,
back
that's
into-
the challenge as far as making it rotate from this way into.
Right, I mean, there's probably gonna be something in the way.
Right.
Because you have to hook an alternator to that shaft, right?
Yeah.
So again, you talked about back pressure.
Our intention is to have a set of bevel gears at the end of the turbine shaft with another vertical shaft coming out the edge of the pipe connected to the.
Put it outside of the airflow.
Okay.
And it would have to be smaller bevel gears so it doesn't really go
Right.
through the whole flow.
It's a possibility.
Yeah.
So you're gonna have something outside of the end of the tailpipe? So wouldn't that attract vandalism or interest from people? How do you address that?
It will be a small component because it will be an alternator, so it probably won't be enough to, I guess.
To attract attention and
attract
vandalism?
attention. And if anything, we can move the alternator to another position. We just route the.
I would say so.
Yeah, don't do that.
I'd say so. Move it to the underside of the car. So, you could make some kind of a bend in the exhaust pipe, and you could use that bend to tap out and use the extra apparatus to catch the energy and convert it. Does that make sense?
Yeah, yes, it does.
about the amount of energy that we expect to collect there, as long as you estimate the potential energy upstream.
Yes, right.
So you already have a reference.
Right,
And it's
right.
worth to do it. As
Yeah,
long as
yeah,
a lot
that's what I'm curious.
of energy
Yeah.
that you're wasting.
Right.
Right after, depends on your overall efficiency, then you will estimate how much energy can you use from that potential energy as well.
Absolutely. Yeah, just I'm curious because,
Yes, but that number is
It's
a good
certainly-
point, that's a
yeah,
good point. We can add that as a reference. We
Right.
expect, I mean, the amount of potential energy is such,
yeah.
and then from there, everything else will be less than that.
And you can kind of maybe estimate your efficiency of the flow and things like
As
that.
well, yes, correct.
Could we see your timeline and cost analysis?
We didn't post it on the thing as far as cost analysis. We have a 3D printer already, so there's no cost. And the actual printing the parts, it's like $2 to print an actual turbine as far as for testing. And then we would do simulation testing on how it works prior to actually building the prototype.
What about the design of the fins themselves? Have you guys thought about specifically like the aerodynamics behind it?
Not specifically, right now it's just a teardrop shape.
Sure.
But that's one of the designs we'll be looking into,
Okay.
the profile.
What about timeline? You don't have timeline?
We didn't, unfortunately, we didn't put it on the presentation.
So you need two additional slides, one
Yeah.
dealing with
Timeline
cost
and
and one
cost.
dealing with timeline.
And one flow components.
And you won't be able to get our input
Local.
on whether or not the font size and all of that is adequate. So you may have to use some independent judgment in that regard, right?
Was the font size good for this?
Well, the font size should be read back here. So-
Okay, no, I'm asking.
But for the previous timelines, the font size was too small.
Oh,
You couldn't
okay.
read, so
Gotcha.
you-
Oh, you're talking about the font for the time, okay.
Right.
I thought you were talking about
You're gonna have a description of each of the line items, so the font size for that, and the graphics that you're gonna have, the bar chart,
Mhm.
whatever information you're gonna have associated with that for the schedule. Those font sizes should be readable from this distance.
Okay.
the cost analysis, you didn't put it on the slide, but do you have an estimate?
I believe we have roughly around 200 for all materials.
$200 for actual prototype.
Okay.
What do you think it will cost once you mass produce it?
Well, we have to look at the different prices of the metals, especially if this is going to be an exhaust pipe, depending on where we put it on the location. Generally, exhaust pipes towards the end run from 200 to 300 degrees Celsius. And if it's something like that, we can use an alloy aluminum. If it's closer to the actual engine, it could generate a higher temperature.
We may want to have a comment like that or be ready to answer questions like that.
Do you have another questions? Okay, thank you.
Okay?